All right, you guys, I'm just going to run through this review. It'll probably be two parts, but we'll see how far I can get on this first video. So here we go. Don't forget, you can have your formula chart handy. It has a lot of quadratic information on your STAR formula chart that you'll be able to use on your test. Like these first two questions. All right, the first one says, what is the standard form of a quadratic? Again, so that's just going to be our standard form, ax squared plus bx plus c. Please make sure you put the y equals in the front, right? If you don't put the y equals, I'm going to count it half wrong, right? Because a quadratic equation needs to have a y equals on it and not just be the expression, okay? The next one is, what is the vertex form? So the vertex form is a parentheses x minus h squared and then plus k, right? And remember, we love vertex form because the hk, right, is the vertex, right? So just reminding you of that. Remember, the a is the vertical stretch and all that good stuff. Oops. All right, number two says identify the vertex from the table. So I just want to remind you that a parabola, right, let me just draw a quick little parabola here, right? Every parabola has a vertex and every parabola has an axis of symmetry, right? And so that vertex point is kind of like the mirror of the quadratic function. So I know that I have little reflection buddies on this side, right? Every point has a mirror image on the side, right? And then I know this point will have a mirror image on the side, and so on and so forth, right? So if we're given a table of values, sometimes we can justify what we think the vertex is by looking for those reflection buddies. So I'm kind of hoping on this table, you'll notice that there's a 7y value and another 7y value. And that's what's reflecting, right? It's the height that's reflecting. So it's the y values. And then you'll notice we have a 4 over here and we have a 4 over here. So these are clearly reflection buddies of one another, right? If I had another point over here, it would be -1 to match this guy. And so whatever point is in between all those reflection buddies, right, that's going to be our vertex, right? And so that 3, 8 is our vertex because he's the point in the middle of all the reflection buddies. Okay. All right, same thing happening on this vertical table over here, right? I'm looking for the y values that are repeating, right? So here is 2 7s. Right, and then of course I have a 10. Oops, oh goodness. Okay, that's really weird. Sorry about that. Draw my lines again. There we go. And we've got a 10 here, and I guarantee if we were to continue the table, right, there would be a 10 right here, right? And so what we really care about though is what guy is in the middle of all those reflection buddies, and that would be 3, 6. Right, and so that is going to be our vertex. Now, not every single table is going to show you reflection buddies because some of them might be quadratic regression models, right? And so it's not going to be exact, right? But in this case, these two tables are. All right, 3 and 4, we are graphing the function and then identifying its features. You are more than welcome to use Desmos to help you out here if you need it. I'm going to go ahead and just notice that this first one is in vertex form, right? And so clearly the HK, right? I know right away that my vertex is, remember, it's the opposite of the number that you see in the parentheses. So 1, 4 is going to be our vertex. I'm going to go ahead and plot that, right? So 1, 4. I also know that this is opening up because it has a +1 for the A value. So I know, let me change colors on that, sorry. So I know it's opening up. Okay, now because the A value is 1, that means our parent function movement is going to remain the same. So over 1, up 1, over 2, up 4, and then I can get his little reflection buddies in there. Right, and that's, oh, apparently I can't do reflection buddies properly. Sorry. There you go. And then here. And that's going to be our nice, pretty parabola. Hopefully. See if it'll Do a nice pretty one for me here. It is not. Yikes. You know what? I'm just going to put it on those points. There you go, if it'll let me. All right. And again, your drawing doesn't have to be perfect, right? But again, go to Desmos. Here we go. Let me just hop over to Desmos really quick. All right, I can totally type that in. X minus 1 parentheses squared plus 4. All right, let me go back to the home screen. All right, and there you go, right? And you can totally see all those exact points that you need to plot on your graph. Remember, don't just graph some random parabola, right? And you need to make sure that you're doing nice, pretty points. Okay. All right, so now that we have it graphed, we should be able to answer all these questions here. Is the vertex a max or a min? Well, it's at the bottom of the valley, right? So we know that he is the minimum value because he's the lowest point. The axis of symmetry is, of course, the vertical line that passes through the parabola, and that's always going to be an x equals equation, and it's always going to be x equals 1, right? Whatever the vertex x value is, that's the value there. Let's see, our y-intercept is where it crosses the y-axis, so that looks like it is at 0, 5. And again, you can go to Desmos, and you can just click on the y-intercept there. You can also click on the vertex, right? It'll tell you what those special points are that are on the parabola. Okay. The zeros. Well, zeros, remember, is just another name for x-intercepts or roots or solutions, and that's where it crosses the x-axis, and this parabola is clearly never going to cross the x-axis, right? So he has none, right? He has no real solutions here. Let me just... All right, no real solutions. All right, domain and range. Well, remember, domain is how wide the parabola spans. And remember, this guy is just going to keep getting wider and wider and wider forever and ever and ever. So he's going to hit every x value. But he's not going to hit every y value, right? Because he's trying to go down forever and ever and ever. But he hits a wall, right? And here's his wall, right? I'm going to put wall. There you go. All right, so he's dipping down. He's hitting a y value of 4 and then turning back up. So that means all of our range, or all of our y values, is everything where y is greater than or equal to 4. Okay. Please notice that whatever, just trying to make little connections here, whatever the y value is of your vertex, that number has to be in your range, right? Because that's going to either be the highest or lowest point representing where that wall is located that your parabola is going to hit. Okay. All right. On number 4, we have a little bit of a problem on number 4 because it is not set equal to 0. So I'm going to bring my positive 6x term to the other side and get him set equal to 0. Or you can put it as y equals. It doesn't matter either way. So 3x squared minus 6x, because when I bring a positive 6x term to the other side, it's going to turn negative. So this is what I want to graph. Please notice that is in standard form. Here, let me write over here. This was vertex form. Right, and this is standard form. Okay. Now, if you want, you can do all the work necessary to graph it in standard form, or you can just use Desmos, right? Either one is really fine with me. So 3x squared minus 6x. I'm going to go to Desmos. I'm going to type that in, 3x squared minus 6x. And I'm going to go find all those key points, right? Just tap on those gray dots, and they're going to tell me all my little key points there. So let's see. Our vertex is at 1, negative 3. Go back to here. I'm just going to graph him really quick. So 1, negative 3. And then our zeros were at 0 and 2. And that's really enough points. Let's see, our A value is 3. So instead of going over 2 up 4, we're going over 2 up 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Technically, these would also be our points. 4, 5, 6, 7, 8, 9, 10, 11, 12. So here. I'm fine with just getting those first three though. But I'm really hoping that makes a nice pretty parabola. It did not. Okay, let's try that again. You know, I'm going to keep doing this until I get a nice pretty parabola. There we go. That'll work. I'm just going to put my... Actually, you know what? I'm going to put that dot here. Thank goodness for notability, right? No, that's not going through that point. Okay, this is not liking me. Okay. There we go. I'm just going to do these guys. I don't need to get those guys up there. Okay, so there's our parabola. All right, now we should be able to fill in the rest of this information pretty easily, right? Our vertex was at 1, -3. It's definitely a minimum again because it's opening up and it's the bottom of the parabola, so it's the lowest possible value. Our axis of symmetry is x equals 1. Right, remember, that's our vertical line that splits the parabola in half, and it also has to have the exact same x value as your vertex since the vertex lies on your axis of symmetry. Let's see, the y-intercept was 0, 0 because it's going through the origin. Remember, roots are also known as zeros, solutions, x-intercepts, right? So when it says roots, it's asking us for those x-intercepts, which are at 0, 0 and 2, 0. The domain is, of course, all real numbers. And then the range, we need to go find the wall, right? So he's going down, 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 and then he hits the wall. Right? And the wall has a y value of -3. So our entire graph is above that wall. So y is everything greater than or equal to -3. And again, you know it has to have a -3 in it because that is the y value of the vertex. Right? And so we have to include that in our range because that's going to be our maximum value. Okay. We got 2 more of these. All right, so here we go. Next one, this is clearly in vertex form. I'll write that here, vertex form, just so you notice it. Something I notice about this is that my HK is -5, and then there's technically a +0 hanging off on the end there, right? So if you're doing this all by hand without Desmos, right, then I know that my vertex is -5, 0. Right, just by looking at the HK there. Right, so here's my vertex at -5, 0. I know he's going to open down because of the negative a value. And that 2 tells me he's being vertically stretched by 2. So instead of going over 1, down 1, I'm going to be going over 1, down 2. And instead of going over 2, down 4, I'm going to go over 2, down 8. 4, 6, 8. All right, then of course I can get his little reflection buddies on the other side. And voila, that's going to be our nice pretty parabola right there. Maybe. I don't know why it's not drawing my parabolas for me. Here we go, that was better. Good enough. Doesn't need to be perfect. Okay. And if you don't understand how to graph it by hand, right, or if you're still struggling with that, then just type it into Desmos, right, and go find those key points in Desmos. Okay, nothing wrong with that. All right, filling in the rest of our information, though, now that we have our graph, clearly that vertex is a maximum, right, because he's definitely the highest point he's the top of the mountain, right, that this will ever reach. Our axis of symmetry is going to be x equals -5. Again, it has to be x equals -5 because it's going through the vertex. Our y-intercept. Now, this one, he does have a y-intercept because every parabola does, but it's going to be way down here, right? So I'm definitely going to go to Desmos to help me out with that one. So here we go, -2 parentheses x plus 5 parentheses squared. All right, so there's our function. I'm going to kind of manipulate my screen a little bit so I can see that. So there's our vertex of negative 5, 0. And then here's our y-intercept, right? So our y-intercept is at 0, negative 50. Okay, so I'm going to go ahead and write that in there. So 0, negative 50. So just because you can't see it on our little 10 by 10 graph, right, doesn't mean it doesn't have a y-intercept, right? It's going to cross eventually because the domain is all real numbers, right? Because he keeps getting wider forever. So he's eventually going to hit that y-axis. Our x-intercepts or our solutions are negative 5, 0 because the vertex is the solution because it's sitting on the x-axis. The domain is all real numbers. And the range, of course, the parabola is trying to go up forever and ever and ever from left to right, but he hits a wall, right? And here's his wall. And that wall has a y value of 0, and our entire graph is below the wall. So y is everything less than or equal to 0. Once again, I know the range has to have a 0 in it because that is the y value of the vertex. Okay. All right, last one. Looks like this guy is in standard form. So it's just something I want to notice. Again, you can find the vertex and do all that by hand if you'd like. I'm going to go ahead and just practice that really quick just because I haven't had to at this point. So remember to find the vertex or the axis of symmetry first. Is that formula negative b over 2a? You can only do this when it's in standard form though. So if x equals negative b, well, our b value is 4. All right, so negative 4. And our a value is the understood 1 in the front, so 2 times 1. So negative 4 divided by 2 is going to give us negative 2. Okay, so I know that the axis of symmetry is at x equals negative 2. Oops. So I'm going to just draw my little dashed line right here. So I know my vertex has to be somewhere on this axis of symmetry. All right, but I need to go figure out what that is. So, but what I do know that the vertex has an x value of negative 2 because he has to lie on that line, that x equals negative 2 line. So what we need to do is we need to find what is the y when x is negative 2. Well, that's easy because I can just go in here and I can put in a negative 2 everywhere I see an x. Make sure you put those in parentheses. Anytime you substitute a number, you definitely want to use parentheses. And so you can just type all that in your calculator or you can just do it in your head, right? So you get 4 minus 8, which is negative 4, minus another 4 gives us negative 8. And so that answers our question mark, right? I know that this is negative 8. There we go. Put some little arrows, kind of map our way there. Okay, so negative 2, negative 8. So here's our vertex. Now, if you don't feel like doing all of that work, it's okay. You can use Desmos, right? I'm just going to go into Desmos really quick because I'm going to double check my math because what if I made a silly mistake somewhere? I'm going to make sure that my vertex is actually negative 2, negative 8. Let's see, plus 4x minus 4. Click on that. And it is. Yay. Right, negative 2, negative 8. So I did all my math correctly. And while I'm here, I may as well go snag my zeros. All right, which we can actually do by hand. But we're going to go ahead and accept these answers on this particular problem, though. We'll do the harder ones later where we get the exact answers. These are clearly rounded answers, right? These are not exact because Desmos, anytime you see 3 decimals and it's not ending in a 5, then it's probably going to be a rounded decimal. So negative 4.828 and roughly positive 0.828. So I'm just going to take those and put them in as my solutions while they're on my top of my head here. So negative 4.828, comma 0, and positive 0.828, comma 0. Okay. And the domain, of course, is all real numbers. Let me fill in everything else. The vertex was negative 2, negative 8. He's definitely a minimum because he opens up. And I'm just going to graph like negative 4.8, like about here-ish. And then the positive 0.8 about here, you can see that those are definitely reflection buddies of one another. Right, so I should be able to draw. Here we go again. All right, I'm just going to let that go because I'm not going to sit here for 10 minutes trying to get a nice, pretty parabola. There you go. That's good enough. All right. We already know our axis of symmetry is x equals -2 because we found that by hand. Our y-intercept, oh, that's a good question, right? Our y-intercept, I know the y-intercept is 0, -4 because when we're in standard form, right, the c value is the y-intercept. If you happen to forget that little fact, that's okay. Desmos to the rescue. I'm just going to go tap on my y-intercept point, and it tells me that it's -4. Okay. And then, of course, the range, right? Our graph's trying to go down forever and ever and ever, but it hits a wall and then has to turn back around, right? So clearly, the y value of that wall is -8, and our graph is above it. So y is everything greater than or equal to -8. Okay. All right. Let's see. Our next question is talking about the transformations. So if we start with the parent quadratic function, we want to write a function that's been reflected across the, okay, I'm just going to write, g of x instead of f of x because we're writing a new function, so I don't want to name it f of x again. So I'm just going to call it g of x. You can call it whatever you want. So this is technically our parent function, and I'm going to try to color code this so you can see what's happening here. So we want one that's been reflected across the y-axis. Well, that, of course, means it needs a negative in the front, right? That means it's upside down, right? When you reflect it across the x-axis, it's opening down, so we need that negative in the front. All right, next up, it's being shifted left 4 units. Okay, left is a horizontal movement, so that left 4 needs to be trapped inside with the x. So I'm going to erase that. And left 4, so we want +4 inside with the x, because it's always the opposite number that's inside with the parentheses. So if I saw that +4, I would know to go left 4. All right, our next one is we want it to be vertically compressed. Vertically compressed means we need a fraction that's less than 1 on the outside of the parenthesis. You can pick any number you want. I'm just going to pick 1/2. So I'm going to put that, oops. I'm just going to squeeze that in there, right? But this can be any number less than 1. Any number less than 1. Right, because that means we're smashing it to half of its original height, right, is what that fraction is telling us. So we're vertically compressing. And then lastly, use purple. We want to shift it up 3. Well, that's a vertical movement, so that means that's our k value. So we want to go up 3. And there you have it, right? There is our new g of x function that has transformed our parent function. Okay. All right, number 8 is going backwards, right? They're giving you the function, and they want you to name all of the transformations that are happening. So let's see. Remember, here is our x squared right here. So it looks like we have 1. Oops. All right, we've got the negative that tells us something. We have the 3 that tells us something. We have this -2 hanging out in here, which tells us something. And then we have the -1 on the end that tells us something. Okay, so there's actually 4 transformations happening here. So let's just go through them. I'm just going to go left to right. So the first one, I'm going to kind of color code it here. The first one is the negative. Well, of course, that means it's opening down, so that's a reflection over the x-axis. Okay, so that's number 1. Number 2 is that 3 multiplier, right? And so that means that when you see a number that's greater than 1, then that means it's being vertically stretched, right? We're taking the parabola and we're pulling up on the arrows and we're making it 3 times taller than it normally is. So this is a vertical stretch by factor of 3. And remember that naturally is going to make it narrower. I'm just putting that little side note in here, right? If I were to take anything and stretch it twice as or 3 times taller than it normally is, it's going to get skinnier. Okay. And then number 3, right, that -2, remember it's always the opposite. I know it's trapped inside with the X, so it has to be a horizontal movement. So this one is going to be a shift right 2. And then lastly, our -1, that's a vertical shift, and it's negative, so it's going down 1. Okay, so there are our 4 transformations. All right, number 9, create 2 equations, one that's wider, a wider parabola, and one that is narrower. Okay, so here we go. Let's do the wider parabola first. All right, so a wider parabola, I don't really care about anything else in this equation other than the A value, right? The A value is what determines whether we are narrower or wider, right? It doesn't matter if it's in vertex form or standard form. It's all about the A value. So if I want it to be wider, that means I need a smaller number than what I currently have, right? Right now it has a vertical stretch of 3. If I press it down and make it a smaller number, it's going to automatically make my function wider, right? So y equals, so as long as you're putting any number less than 3, right? So I'm just going to put a 2. 2x squared minus 8x plus 5. Everything else can stay the same. All right, I'm just picking any number less than 3. You can pick 1. You can pick a half. Right, so I'm just going to put any number less than 3. Right, like I said, it can be a fraction. Okay, anything you want to do there. All right, and then our last one, we're going to do the narrower parabola. And of course, if I want to make something narrower, that means I need to vertically stretch it more than what it currently already is. So I need a number greater than 3. So I'm just picking any number greater than 3 and keeping everything else the exact same. All right, and so there's obviously infinite answers here as long as you give me a number in the front, an A value that's greater than 3. Okay. All right, so that's how that is going to work. All right, moving on to number 10. So number 10, what is the axis of symmetry formula? Okay, well, this is on your formula chart. So x equals negative b over 2 times a. Okay. All right, so we're going to get some practice. I know I already did one kind of by hand in the previous problem, but now we're going to do all of this by hand. So it says calculate the axis of symmetry and the vertex. And then once you have that done, write the equation in vertex form, because all of these are in standard form right now, right? So remember when we did this in class, right? When we go back and forth between standard form and vertex form and vice versa, okay? So first thing is we need to check to make sure that it's in standard form, right? And it's in nice descending order, right? X squared, then x's, then constants. So this guy's ready to go. So this is our A value is 4. Our B value is negative 8, and our C value is 3. I'm going to write those down on the side. There we go, like we did in class. So the A is 4, the B is negative 8, and the C is positive 3. Okay, so for axis of symmetry, we're going to do the x equals negative b over 2a formula. Now that b is already negative, so when I want negative b, that's going to be negative 8, which will just turn it into a positive. And then 2 times 4, which of course gives us 8 divided by 8. So we're going to get x equals 1. That's our axis of symmetry. Okay, now we're going to use that axis of symmetry to go find the vertex, right? So the vertex, clearly we know he already has an x value of 1. but we need to go find the y when x is 1. So we're just simply going to use our formula. I'm going to use y instead of f of x. And everywhere I see an x, I'm going to substitute a 1. Again, just please type all that in your calculator. All right. And when we put all that in there, I believe we're going to get a y value of -1, which is then, of course, what you're going to use to go plug in that missing y value of your vertex. Right, so -1. There we go. Now, before I write my final equation, I would highly suggest you check this in Desmos. I'm going to go check it really quick. On your test, you have to show work or you don't get any credit for this, right? And so you can't just use Desmos all the time, but you can use it to check your answers. So 4x squared minus 8x plus 3. I'm going to go click on that vertex. Yay, it is 1, -1. All right, that makes me feel good. So now that I know that that's 1, -1, I should be able to go write my equation in vertex form. All right, so remember, vertex form is y equals ax minus h squared plus k. So here we go, y equals, remember the a value in standard form is the same as the a value in vertex form. So that a value of 4 just comes down, and then x minus, well, I already know my h value is 1, so x minus 1 squared, and my k value is the -1. And so this should be my vertex form. Now, you better bet on a test, I'm going to go check this and just make doubly sure that I didn't make a silly sign error or somewhere along the way. So I'm going to keep my standard form in there, and I'm going to type in what I just got from my vertex form, because it should be the exact same. X minus 1 squared minus 1. And there you have it, right? Notice I'm hopping back and forth between them, right? And they're the exact same parabola. They're just different. They're just written in different forms. Okay, so that's how I know I did my problem 100% correct. Okay. All right, I'm going to go ahead and run through these next two really quick. I do want you to notice that on on number 12, it is not in standard form. Remember, we always want the x squared term to be written first. And don't forget that he's the negative, right? The negative or the minus sign belongs to him. And this 8x is positive, so he gets a plus sign when I kick him out to the right. Okay, so and there is technically an understood 0 hanging off the end there. The reason why that's so important is because when I go off to the side and find my A's, B's, and C's, right, my A has to be -2 because the A is always the number in front of the x squared term. The B is +8, and of course the C is 0 because there's no C value on the end there. So then when I go calculate my x equals -b over 2a for my axis of symmetry, I get -8 over 2 times -2, which is 8 divided by -4, so x is -2. Oh wait, I forgot my negative. I'm so sorry. It's not -2. Sorry about that. That is +2. Forgot to carry over my negative. So sorry, -8 divided by -4, so +2. Okay, now we're good. All right, now we need to go find that vertex, which clearly already I know has an x value of 2. Right, so I need to go calculate the y value when x is 2. So y equals -2 squared plus 8 times 2. And you can type that into the original or the newly arranged one. That's totally up to you. And when I type all of that into my calculator, I'm getting 8. Right, and so that is where that number is coming from. Now I'm just going to go do a quick double check, right, in Notability, or I'm sorry, in Desmos. I'm going to type in that function. I'm just going to type in the original one that they gave me. It doesn't matter. -2x squared. I'm going to tap on that. Yay, 2,8. That's what I got, right? So I'm looking good so far. All right, going back to Notability. So now I want to write my equation in vertex form. So y equals, remember, he's going to have the same a value, which is the -2. So -2, and then all you have to do is put in your hk. So x minus 2 squared plus 8. And again, I'm going to make doubly sure. I'm going to go back to Desmos, and I'm just going to type what I just wrote down, -2 parentheses x minus 2 squared plus 8. All right, and then notice I can toggle back and forth between them, and they're the exact same parabola. So I know I did all my work correctly. All right, last one really quick in this section, right? It's in nice, pretty standard form, so it looks like we're good to go, right? The A is 4, the B is 8, and the C is -3. All right, so here we go. X equals -b over 2a, which is going to give us -8 over 2 times 4, which is 8. So I'll just go ahead and keep writing. So x equals -1. Okay, go find that vertex. Again, it's the same steps over and over again. The vertex is going to have an x value of -1. Okay, so I need to go figure out what is the y when x is -1. So I'm going to rewrite my entire function, but everywhere I see an x, I'm going to sub in a -1. And when I type all that into my calculator, I get -7. All right, again, I'm going to go check that really quick. I don't want to write my equation if that's incorrect. So I'm going to go back to here. I'm going to clear that out. I'm going to type in my function 4x squared plus 8x minus 3. Check my little vertex. Yay, -1, -7. That's what I got. All right, so then I'm going to go back to Notability here. All right, so now I should be able to type my function. Y equals, going to have the same a value of +4, and then just throw in your hk, but it's the opposite of the h, and then the -7. And again, I know it's a little time consuming, but it's totally worth every second of going back to Desmos and typing in our new vertex form of 4 parentheses x plus 1 squared minus 7. And there it is, right? Toggle back and forth, the exact same parabola. So now I know that that is correct, right? I'm going to put little check marks next to all of these because I've checked them in Desmos, and I'm 100% sure I didn't make a silly math mistake anywhere along the way there. Okay. All right. I'm going to stop here at this point in the video for part 1. Please rejoin me again for the next video where we start back on number 14.